You know, I've been walking around in the park near my house trying to figure out what the topic for the next video is going to be. And I gotta admit, I just keep getting distracted by all these pine cones. They're so sticky. Whoa. There are quite a lot of pine cones around this fir tree. Pine cones around this fir tree. Oh, cool. This hemlock is so young, it doesn't even have any pine cones on it. No pine cones on this hemlock. No pine cones. The pine cones on a hemlock. Wait a minute. Okay, so what the heck is going on here? How is it that we can look at something that looks like this, like this, like this, and like these, and refer to them all as the same thing? Why do we call them all pine cones? Well, there's probably a couple reasons for it. One of which might be the fact that these are all conifer, they all come from conifer trees. Trees that, well, bear cones, right? Conifer, tree, cone. So they're all related, and they're all in the pine family. And pine is a really old word that has a little bit of an ambiguous origin, but it probably means something like to swell up or to be overflowing with. And that name is probably in reference to the sap that often comes out of conifer trees when they're wounded. They pour sap out and are overflowing with it. So, okay, great, video done. We answered the question. But, you know, there's another layer to this too, and it's the fact that oftentimes when we live in cities or we spend our time occupied with jobs or school or other types of activities, and we're not spending time outside and getting close to the species around us, we tend to forget the details, or we never learn them in the first place. And so what we're going to do today is we're going to explore the conifer trees here in the Pacific Northwest, and we're going to get to know this family a little better. We'll take it from the family name down to the individuals. So let's go check it out. We'll explore some of the most common conifers in the Pacific Northwest. We're going to get to know the Pacific Northwest's conifers. We're going to need a way to tell them apart. So we're going to have to dig into the details a little bit more to be able to determine exactly who's who and tell which parts are similar and which parts are different. So there are 4 traits that we're going to use. The overall shape, also known as vibes. The cones. The bark. And the needles. I don't like needles. Well, not that kind. I know. Since we're talking about the pine family, why don't we start out with our true pine, and then we'll look at distinguishing features from some of the other types of trees from there. So right behind me is the shore pine. There's a few pines that we have here in the Northwest, but this one's the most common. It's appropriately named. As you can see, we're down here on the shore. And they're commonly found growing right next to the ocean because they can tolerate really cruddy soil. They can be in places where it's very salty, it's very rocky, it's very minerally, there's not a lot of nutrients. And so they're able to grow pretty close to the shoreline where a soil layer hasn't built up. Interestingly enough, in east of the mountains, in eastern Washington, eastern Oregon, and the Midwest of the United States, these are called lodgepole pine. Because what they try to do is grow up really straight. You can see this one is trying to go totally vertical, but because the wind is so strong in many of the places where they live, these trees will often twist or contort, which actually leads to their scientific name, Pinus, pine, contorta, contort or twist. And so you'll see them kind of getting into all these cool, weird shapes. Zooming in a bit, we can get a really good look at the needles and the cones on this pine. If you notice, the needles go all the way around the branch, but they do so in these kind of clustery fluffs. So there's lots of floofs of needles right here, and then they stop. And then you go to a new part of the branch and it'll fluff out again. And so that's pretty distinct on pines. And they also tend to have really long needles. And shore pine always has its needles in pairs. There's 2 needles together. Sometimes other species, like the western white pine, will have 5 needles together. And so you'll see those different numbers if you're trying to figure out exactly which pine you're looking at. So 2 needles is the shore pine. And as we go a little further up the branch, you can see the cones. They're very classic pine cone. They're really hard, and in fact, they've also got a little tiny prickle on them. So if you pinch these, they can actually kind of hurt to grab, or throw at your brother. Ask me how I know. But you can see they've got almost spherical cones with really tough scales that are hard and have a little prickle on them. The bark on shore pines will be this kind of reddish brown or almost gray color, and especially the younger bark in between the gaps will be kind of a little more red. But it's tough, but it's also almost papery. It's kind of like gets its strength from kind of like, if you think about, one sheet of paper is pretty hard to rip or to punch through, but 300 sheets of paper are very difficult to rip or punch through. And so that's kind of how the shore pine builds their bark. But because they have this softer bark and make a lot of pitch, I'm going to show you a wound on this one. It's just thick with sap. They are really susceptible to fires. On this older tree, you can really see how those individual layers of bark build up over time to make for a stronger and sturdier bark, even though each individual piece is fairly weak. That tall, straight tree in the center of the shot in the background is a grand fir. So it's one of our native fir trees. It's the most common one. Firs have tighter crowns. So what that means is that the branches don't grow that far away from the trunk compared to how tall they get. The grand fir is called that because it can get very big. Almost 240 feet tall is the record tree, which is pretty massive. But it'll have those branches that stay kind of close and form sort of a triangle from the top. And that's how you can see the fir from far away. Now we're also looking up at the top of the tree because way up here is where you would find the cones. And as much as I want to climb this tree and go find the cones for you, it wouldn't be safe for me to do that today. So I did get kind of lucky though, and a cone from a different type of fir. This one is from an ornamental fir. I don't know what species, but it's another one that was brought here in the park. Fell down and actually, luckily enough, didn't break apart. And that's cool because firs have a kind of unique strategy with their cones. They point up from the branch. So if my hand is the branch, my fingers, they would be growing this way, not this way. And they're kind of broadcasting to birds and squirrels, hey, 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 I've got food and seeds in here, come eat me. And so the skin of this is actually pretty soft. Like, I can't, let's see if I can get it in focus here. There we go. I can peel these scales open relatively easily. And so the cones, or the seeds inside the cone, can be eaten by animals and they can head to the forest. So you often won't find these on the ground actually because they're so soft that they'll decay by the time you get to winter or spring. But we got lucky and we got to see one today. So grand fir bark is usually this gray color, although you might also be able to see there's a little bit of a powdery blue on here. That's actually a lichen. Lots of these trees have powder lichens that grow on them, or mosses as well. But it'll have that kind of grayish color, especially when it's mature. This is probably a pretty old one. But it'll have very dense bark. So it's not very thick, but it's very hard. So it's got a lot of strength to it. And it will grow in these kind of shorter crags. So you'll see all these kind of layers or little cliffs, but they're not very deep, and the individual plateaus are not that long. And when the tree is younger, you won't see these crags at all. The bark will be coated in these kind of little blisters. They're almost like little pimples that are full of sap. And that's pretty distinct on firs in general. This one also has a little bit of English ivy growing on it, which is actually an invasive plant. It came from Europe and is overwhelming a lot of the trees in the area. So I'm gonna take some of this off, see if I can get it all in one strip. Oh, dang it. And what we can do by taking a little bit of this ivy off is say thank you to this tree for sharing its information with us. That's always a nice thing to do. As far as the needles go, a little tool you can remember is that firs are flat. Their needles basically grow flat and parallel to the branch. They don't go all the way around, just across. Looking at a Sitka spruce from a distance at their shape, they really give you the vibe of someone wearing like a flowing dress or a long cloak. The branches arch out and up, and then they always have those little kind of chandelier-y like smaller branches hanging down where the needles are. And they honestly kind of remind me, if you've got a bit of a deep cut for the ocean nerds out there, but it's kind of like the tentacles on a conifer, if you've ever seen those. Bark on Sitka spruce is really scaly. So if we take a close look at it, you can see it's got plateaus and crags like the grand fir does, but each of the individual plateaus is more like a square or like a short rectangle or kind of round. So it almost looks like lizard skin as you go up. And you'll often see it'll flake off, leaving these kind of more reddish patches from behind where there was more gray on the outer bark. Unlike on the grand fir, the needles on the Sitka spruce go all the way around the branch. So you can see they go in a circle around it, coming out of the top, the bottom, and the sides. And but like the grand fir, there is a little mnemonic we can use. If you remember, firs are flat, spruce are spiky. So if you touch a Sitka spruce, they're really prickly. So spruce are spiky. Ow, ow, ow. The cones on a Sitka spruce are long and skinny, and just like the bark, they almost look like they have lizard scales, and they'll hang down from the branch, and you'll often find lots of them down on the ground. And actually, now that I think about it, lizard scales, dark green, spiky, formal wear. I think Godzilla's going to the prom. When conifer trees are growing in dense forests, they tend to lose their lower branches as they get taller because there's so much shade further down that they're kind of wasting energy by having leaves that can't collect as much sunlight. So you'll often see them with large bushy crowns at the top and very few branches on the lower side. And that's true for this western hemlock that we're looking at right now too. It is this one here in the middle. And hemlocks will have this kind of almost like bushy or kind of short chandelier shape, kind of stubbier branches and less dramatically drooping than the Sitka spruce, but similar in some regards. The other thing you can always tell with a hemlock from a distance is to look at the very, very top of the crown and look for that peak that tips over. It's always drooping at the top. Other trees around it, like you can see, have more vertical tops, but the western hemlock will always have that droopy peak. Now that we're at the bottom of this hemlock over here, I'm looking around on the ground and I can see that there are just cones everywhere. Dozens, maybe hundreds, I mean honestly maybe even thousands in the immediate area around this trunk. There are just tons and tons of them. And these hemlock cones are really distinct. They are the smallest cones you're going to find in the forest. They're kind of papery, and they hang down from the top of the branch like that. And they'll do it in tight clusters, and they make a lot of cones. And that probably has something to do with the fact that hemlocks are one of the last trees to grow in the forest. And that's because they're slow growing in general, but also because they really love to grow off of the dead stumps or fallen logs of other trees. So in order for them to be really successful in a forest, you have to have had whole cycles of trees being born, growing up, and dying and starting to decay before you start getting a lot of really healthy hemlocks. And because they're kind of late to the party in terms of collecting the sunlight within the forest, they're more in the shade, they kind of need to throw as many babies out into the world as they possibly can and hope that they'll be able to make their way in the world in any of the available sunlight that's left. So by making lots and lots of little tiny cones, they're able to send a lot of material into the world to be able to hopefully capitalize on the resources. Needles on a hemlock are really tiny. So you can see they're very short compared to the whole branch. And then also they're flat-ish, but not totally flat. You can still see some of them kind of growing out of the top of the branch. So they go all around, but they lay sort of planar. And they're really, really soft. They're very kind of a friendly, gentle conifer tree. Western hemlock bark can be a little hard to distinguish, especially from grand fir bark, because it's also craggy, it's also gray, and it also will often have the same kinds of lichens growing on it that grand firs and other trees do. But if you look at the crags, if you look at the little pits and valleys along in the bark, you'll notice that very few of them are much wider than one or two of my fingers. They're all pretty skinny. And if we go back and look at the grand fir bark, we'll notice that those were quite a bit wider. So that can be a good indicator. And then another thing you can do is you can come up and touch the bark. And hemlock bark is a little bit less dense than grand fir bark, so it feels softer. It's kind of airier and lighter. You can just kind of feel it. So that can be a really good indicator, but they will often both have that blue-green lichen on them and have similar colored bark. So that's another reason that it's great to make sure to use all of the diagnostic tools, the needles, the cones, the bark, and the shape, to make sure you know exactly what you're looking at and not rely on just one. I've got a young cedar here. As it's younger, branches are able to go up and curve towards the sun like this. And then as the one you can see in the ones that are older and taller behind me, as they get bigger, that starts to droop, just like all of us as we get a little older. But you'll see that kind of like fluff to them and a nice graceful curve on those branches. Western red cedar has really distinct bark. If you look at it from further away, one of the things you'll notice is that it is red, like its name suggests, but it's kind of a almost like purplish tint, kind of a maroon red color. And it runs down in these long, narrow strips. So that skinniness of the strips is what helps identify it. But if you get a little closer and you actually touch the tree, one of the things you'll notice is that the bark is incredibly soft. It's actually almost like petting a kind of like rough, wire-haired dog. It's sort of hard to believe you're touching the outside of a tree when you touch cedar bark. Western red cedar needles are also really distinct. So instead of having hundreds of little teeny tiny or long, depending on the type, needles sticking out from the branch at various angles, they're more like scales. So you can see they come out of the branch flat on a plane, so flat like that, not going all the way around. And they kind of form these really cool alternating left, right, left, right, left, right, fractal patterns down the branch. And the branches are super whippy and flexible, and that helps the cedar shed snow so that it can still have its branches exposed to the sun and continue doing photosynthesis, even in the winter during heavy snows. The cones are really tiny, and so they grow out in these dense clusters kind of out on the edge of the branches, about halfway down the leaflet, as you can see there. And these ones are dried out and opened up. They've been on this branch for a while. But when they're fresh, you can tell the western red cedar ones because they will be kind of pointy, almost conical at the top, and then they unfold as they get dry and spill their seeds. All right, now that you've learned the traits of many of our Pacific Northwest conifers, it's challenge time. I'm going to get out of the way of the camera, and there's going to be a tree behind me in the middle of the shot, and it's going to be your job to identify that. I'll help you through it, and we'll go walk and take a closer look to get to some of the details too. See you in a sec. Okay, didn't realize that was over my shoulder in the shot. It's just me out here shooting selfie style. But we're getting a little closer to the tree now, and getting in more. Definitely gives me some Godzilla in a ballroom gown kind of vibes. It's got really drapey branches, but we can get a little closer. Let's take a peek at the needles. Oh yeah, okay, we can see that kind of like chandelier-y look, and it looks like, yeah, the needles are going all the way around the branch, so it's definitely not a fir. Okay, so if we got chandelier-y stuff, longer things hanging down. Oh, here's some cones, cool. Okay, let's take a look. Huh. Okay, they're kind of papery, like the spruce, and they're long like the spruce, but they're not as long, and they're tougher than the spruce, but they're hanging downwards. Huh. Okay, and then there's quite a lot of them. Which kind of makes me think hemlock. Well, let's go look at the bark. It's kind of red and brown like a pine, and it's got lots of layers like the pine, but it's also long, deep crags and plateaus like a hemlock or a grand fir. All right, you got me. I wasn't exactly fair on the challenge. This isn't one of the trees that we've already looked at. It's our final conifer, and it's actually the most common one in the Pacific Northwest. But I left it to last for a reason. I wanted to give us the information that European colonizers would have had when they first came to the Pacific Northwest and started looking at this tree. And they saw that it had some traits that were kind of spruce-like, some traits that were kind of hemlock-like, some traits that were kind of fir-like, some traits that were kind of pine-like, and they couldn't figure out what they wanted to call it. But because of a belief in a sense of superiority of European ways of thinking, everyone assumed this had to be one of the trees that they already understood. So in English, it will most commonly get called the Douglas fir, even though it's definitely not a fir. It doesn't have flat needles. Or in Latin, it will go called the Pseudotsuga, which means fake hemlock, for its genus. But it's not a hemlock. It doesn't have a bendy top. It doesn't have little cones. And largely because of those previous biases and racial prejudices, no one acknowledged or recognized that this tree already had a name from groups of people who had been in relationship with it for tens of thousands of years, and could have told you that this, at least in the language of the ancestors of the Muckleshoot, Duwamish, and Suquamish people who are here in the overlapping territories around where Seattle sits now, in the language of Lushootseed, which is the language of Eastern Puget Sound. This tree is known as Chibidats because when we actually look into the genetics of this tree, it's not related to any of those others. It's its own group of trees, which are only found in Western North America and in East Asia. And so I bring that point up to just highlight that there is a lot of knowledge out there that has been deliberately suppressed or lost because of these biases and sense of superiority. And they were just straight up wrong. We're calling this tree by a name that doesn't make any sense. It's not a fir, it's not a hemlock. So I really encourage you to learn who the indigenous people that have lived where you live now for thousands of years and look into those resources. I'll leave a link in the description for how you can find out who lives on the land that you now call home. And once you do, you can go to those tribes' websites and learn a little bit more about what they want from you in exchange for the knowledge that they're willing to share. I learned this tree from the Tulalip tribes, which are further north. Website has a really cool Lushootseed language tool on it. And so you can actually learn some of the words for the plants or even everyday things in the language of this place. But take that beyond too. Recognize that any information that you're given is a gift, and that gifts are more meaningful when they're given in reciprocity. And so know that gifts are our responsibility as well to acknowledge and validate and improve the lives of the people who gave you those gifts. So I think that brings us back around to the concept that we started at the very beginning of this video, that when we close our eyes to the beauty and diversity of the world around us, we end up calling everything a pine cone. But if we prioritize the time to authentically engage with our neighbors, whether those are humans, arboreal, or beyond, we begin to appreciate everyone for who they truly are and not who we assume them to be. And from there, we can move beyond appreciation to action for everyone's mutual benefit. Thanks for watching. I'm sure I'll see you again soon.